Well, good morning, everyone. Welcome back to another exciting day of mathematics. Whoop, whoop. Warm-up number 43 is on the screen. Let's get started, please. And then I'll go over it briefly right after because we have a bunch of stuff to cover today. Oh, yes. Today we start with functions. Let's go. Let's go. All right, here we go. Number one. Number one, solution set of x such that it's x less than or equal to -1, or it was 2 less than or equal to x. Hands if you got something like that. Okay, good. Number two, c equals 2. Check your works. Hands if you got that. All right. And for those of you that forgot, we need a LCD, or a least common denominator. The least common denominator was 3c, c plus 2, and then you distribute, simplify, and solve. Next, the domain. Everybody by now knows that we're talking about the x values, yes? All these are the domain. And f of x is our range. So our range is 5, 3, 1, -1, -3. Hands if you got that. All right. And our graph. Our graph should look something like that, going downward and passing through +1 of y. Check your work. All right. All right. Copy the agenda, please. Agenda for today, warm-up number 43. We're intro to functions. Yeah, let's go. Let's go. Let's go. This is the funner part of the graphing portion. I love this. That's coming up. And just a reminder, for those of you that in the past you've got overwhelmed by graphing, this year, the word of the year is graphing. So make sure you make it a tutoring, please. I'm here Tuesdays and Thursdays after school. It's free. Let's go. I mean, who doesn't like free, right? And the play sheet cue, it's in Canvas. You go to the Intro to Functions module, and it's in there. Okay? And once again, stay focused, guys, because this is going to go pretty quick. And from this point forward, you know, all I can say is stay focused and do your practice, especially the warm-ups. Some of you somehow are missing the warm-ups, and if you're missing the warm-ups, that means you're missing about 15% of your grade. You're like, how does that? Yeah, the warm-ups are extra practice. They're going to help you for the lessons that are coming, so if you're not doing that practice, there it is. So if you can, try to go to the restrooms before you get here, especially this next section, because we're about to, guys, we only got 3 weeks for November. Then we got December 1 week. We're going to do like a review. Then we have a full week of finals. Let's go. Then Christmas break. Let's go. Because the finals 25% of your grade, only one exam, just FYI. And I was doing the math. Check this out. This is just me, because I you know, I'm a number person. So Monday, Tuesday, Wednesday, Thursday, Friday. I'm going to go easy. 5 minutes. You leave 5 minutes every day for the whole week, that's 25 minutes. In 2 weeks, that's what? 50 minutes, so you're already missing 1 day in 2 weeks. If you leave the class at least 5 minutes every day. However, some of you leave and leave for 10 minutes. That means that in 1 week you're missing 50 minutes. That means you're missing 1 day a week. We've covered so far 10 weeks. So how many days are you missing if you leave every day for 10 minutes? You're missing about 10 days of Algebra 2. Now, I don't know about you, but unless you're a math person like me, you're going to be able to keep up. But if you're missing, I don't know how to make up those 10 days, FYI. BCW. All right? So with that said, copy the objective at the bottom left of your Cornell notes, the packet that you got. I can identify functions. I can identify functions. So we're moving on to functions, guys, and today, like I said, it's going to be so packed with stuff. Make sure you have your stuff ready. You do need a highlighter towards the end. We're going to get into that section of looking at domain and range through the view of the coordinate plane. All right? So, before I give you the definition for functions, let me talk about vocabulary that we talked about already. An order pair or coordinate is made up of X and Y. You're like, we know that, Ms. Q. We covered this in 5th grade. Okay. Let me show you with numbers what that looks like. Example 2, 3. That's an order pair. Which one is X? 2. Which one is Y? 3. Okay. Whenever I give you a bunch of those together, when you put them all together, those are known as a relation. You're not copying this, you're just paying attention. A relation is a bunch of order pairs together, or a collection of order pairs. There they are. And that collection of order pairs are in no particular order. They're just together. However, from there I can ask you some questions such as, what is the domain of that relation? Look at it. See if you remember, tell your neighbor the domain. What is the domain? What does domain stand for? Tell your neighbor, please. Domain. Yeah, domain is all X values. So if I was to give you a relation, your mind is already thinking what? 2, 0, 100, -5, -2. However, when I ask you to write the domain from a relation, look up. This is how you write it. Set notation, -5, -2, 0 to 100. Tell your neighbor what's so particular of writing that domain in that way. What's so particular about it? And of course you saw that it was in what? Ascending order, from least to greatest. Does everybody see that it's from least to greatest? Yes? All right. Also, from that same relation, I can ask you for the Y value. So you remember the name of the Y values. Name of the Y values. All right, Frida, name. Range, very good. So range is 303, 7, -3. However, when I ask you to write the range, look how I write it. So you remember what's so particular of writing the range when I ask you for the range? What's so particular? Two things. One, Alyssa, what's the first thing? Yeah, from least to greatest. What's the second thing that's so particular? Frida. No repeating numbers. That is correct. If you notice here, it was 303. Did I write 3 twice? No. No repeats from least to greatest. That's how you write the domain and the range. We got it? All right. So now that we know what relations are, behind the Cornell notes that you started, there's line paper in the back, right behind it. I want you to copy these next 3, please. We're going to represent a relation using a table, using a graph, and using a mapping diagram. Draw that right there, please. And yes, we're not using that graph paper yet. You're creating your own graph in the back where I give you the line part. Do those 3. I'll give you some time. Copy and go. All right. So we're going to represent a relation these 3 different ways. So a relation, we said it was a bunch of points together. My first point is 2, 3. The next one is -6. Give me a number. 1, okay. And give me one more point. Isabella, go. 4, 2. All right. So Let's write them on the table. 2, 3, negative 6, 1, 4, 2. Do they have any particular order? No. You just write them in the table just to get organized. Let's plot those. 2, 3, 2, 3, negative 6, 1. What? What? And 4, 2. You okay, Noah? Okay. All right. 4, 2. So we know how to represent it as a table. We know how to represent it as a graph. Now as a mapping diagram. Look up really quick so you can see the mapping diagram. Show your neighbor how I write the mapping diagram. What's so particular about it? Yeah, from least to greatest. So I started with negative 6, then I went to 2 and 4. How about the y's? 1, 2, 3. Also from least to greatest. Now, why is this called a mapping diagram? Because as follows is what we do with this. We have to map the value of the x that corresponds to its y. So negative 6 goes to what? To 1, so we need to show it with an arrow. That one goes to that. Next one, 2. 2 goes to what? 3. So that means I'm going to draw an arrow going that way. And the next one, 4, 2, that way. That's why it's called a mapping diagram, because we map values. First, they need to be in order from least to greatest, but then we map to its correspondent y. Okay? So, relation. From 1 to 5, how comfortable are you with these two your presentations? Yeah, 5, 5. Yeah, we've seen this, and like I said, hopefully your Algebra 1 teachers introduced you to all these components, yes? Is it coming back? They're like, yes, Mr. Q, we love this stuff. All right, good. So now that we know what relations are just a bunch of points together. Let's find out what functions are. Go to the prayer model, write this down, function. A function is a relation with that assigns exactly one output value for each input value. So you're going to write this relation that's rare right here, and then write the examples of what the functions might look like pretty soon. There they are. I'll give you some time to copy that. Go. All right. So before I go over the definition and the that relation that I gave you, let me show you the graphs. This one is a linear. I've already been working with this one before. There it is. This one I've also introduced in the past. It's a parabola. And this last one is known as an exponential. An exponential looks something like that. Write that in there, please, so you know what the graphs look like. But notice that we went from y's to now what? F of x. From y's to f of x. Why? Because we're moving into the functions notation. Over here behind Jessica. All right? So, here we go. Function. A relation. Is this a relation? Yes, there's a bunch of points. These are also relations. The only thing, it's showing it in a equation format. That assigns exactly one output value for each input value. What does that mean, Mr. Q? That means, here it goes, here's the key. Ready? That means that if I start with a particular value for x, and I get a certain value for y, if I repeat that again the second time, we should have the same two values. Here he goes. For example, look at this one. Negative 2 has a value of what? Y of 3. Next one. Negative 1 has a y value of 4. 0 has a y value of 5. 1 has a y value of 6. However, look, negative 2 repeats. What value should it have on the y? 3. Does it have a 3 on the second time? Yes, that's why this is a function. Whenever the x value appears again, the y value has to be the exact same. That's what it means, one output for each input value. Now, let me put it in a simple way. Check this out. Let's say I got thirsty and I wanted something to drink. I usually just drink my coffee and water, but for today I'm like, you know what? I'm gonna get a Gatorade, and I like the Gatorades that are the green ones. I don't know the taste. I don't know what it is. So I'm all, Fredo, come forth, and I give him $1.25, and Fredo goes, puts $1.25 in the machine. What button is he gonna press? Green Gatorade. Is that correct? So presses that. What should come out? Green Gatorade. So then all of a sudden, he brings me my green Gatorade. I open it up. I take a nice chug out of it, and you guys are like, man, I got thirsty. And all of a sudden, goes off. Mr. Q, can I go get a Gatorade? Sure, fine. So he gets up. He goes $1.25, and he gets what color? Blue. He likes a blue one. Boom. He presses the blue button. A blue one comes out. Then from there, Dulce goes. Mr. Q, I want to go. All right. Which color? Red. Presses red. Red one comes out. And Fredo's out. Q, I want to go, but I don't have any cash. All right, here. Since you brought me my Gatorade, bam, I'll hook you up. Fredo goes. He's out. I'm going to get a green one. He presses green, and he gets a purple. Is that machine functioning correctly? No. Because why? The same button that you press, you should get the same output on the other side. Is that correct? That's how this works with numbers. The same number that is input the first time, whatever output has to repeat the second time. That's how we know it's a function one-to-one. With that said, copy this next relation for the none example. That none example is a relation, but it's not a function. As you're copying that, think about the question, why is that not a function? Why is that not a function? Why is that relation not a function? Don't say it out loud yet. You're just thinking about it. As you're writing that down, look at it. Now you should have why that is not a function. Talk it over to your neighbor. Let them know why is that not a function. All right. I think Lorena's got it. Very good. Fabian's got it. Juan's got it. Very good. All right. Let's see. Jaden, why is this one not a function? Because of the -2. What about it? Its y is different. Yes, over here we have start with a 3, and then we end up with a 7. That's why this is not a function. That is correct. Hands up, you saw that? Yeah. Once again, whenever you see an x value that it repeats later on, its y value has to be the same. If not, it's not a function. Okay? Now let me show you a graph. You don't have to copy this. Look up. Look up. All right? Whenever they give you a graph, we do something that we call a vertical line test. So let me do a vertical line test. Look up. Here it goes. I draw a vertical line through a graph. If my line, what is it at? If my line touches the graph at 2 spots, then it's not a function. Is that green line crossing that red graph in 2 spots? Yes, Mr. Q, right here and right there. That's why this one is not a function. Watch. What is the coordinate for that point that's on the graph where that intersects? It's -2 of x and 1 of y. What is the coordinate for this one? -2 of x and -2 of y. What do you guys notice? 2 different what? Y values. Okay? So, what makes a function a function? It has to be a what? A relation. And it has to be 1-to-1. Okay? We good? All right. So, we're about to get into more of the graphing, a little bit more, not too much yet, but a little bit more. And we're going to now get into 3 different types of notation that's going to be your home plate for tonight. Before I show you that, though, I'm going to be talking about 2 types of intervals. Look up, don't copy this. An interval is basically a section of a number line without any breaks. Can you picture it? Let's see. Picture it. And I asked you to highlight a section without any breaks. That's what we call an interval. Now, the interval is only 2 types of intervals. The first one is called finite. That means that it has a ending point on both sides. Or an infinite. That means that one or the other side goes to infinity and beyond. So once again, it's finite. That means that it has a stop on both sides. Or infinite, that it keeps going. Now, the symbol that I'm going to be using is a bracket to show that it stops or that it is included. Parentheses to show that it's not included or it keeps going to infinity. Okay? All right. Underneath, there's a table there with graphs. Do you guys see it? I gave you this graph already. Okay, let me give you 3 more graphs. Copy this one, and that one. I'll give you some time for that. Copy in. So here we go. Y'all ready? So we're going to start with the first graph. Ready? We know how to write the inequality. I'm just going to go ahead and practice this one with you because the first column, it says to write the inequality from the graph. Ready? Here it goes. Here goes the process one more time. Where do I start, Mr. Hugh? I start where the dividing point is at. What is my dividing point for the first one? Dividing point is -5. Yes, that is correct. Then the shaded region, this all is represented by X. Okay, so question. All these numbers to the right, what are they, or what is -5 compared to all these numbers to the right? -5 is what? Less than. Yes. -5 is less than all these numbers to the right. Oh, it's -3. My bad. My bad. It's -3. I did that to see if you were paying attention. -3. That is correct. -3 is less than all these values, which are X. Okay. Is this an open point? Yes, so we don't need an equal sign. Now, if I was to turn this around and write it in X terms first, this would be what? X is what? Greater than -3. So I'm going to use this one to use my set notation. Ready? Solution set of X such that, then what do I write? X greater than -3. Here's a new part. Interval notation. What's my dividing point? -3, comma. The arrow points that it's going to the right. Does it ever stop? No, that's what the arrow indicates. So where's it headed to if it doesn't stop? What do we call that? Very good. To infinity and beyond. Yes, it's positive infinity. It keeps going to positive infinity. So here's a question. Do we ever catch up to infinity? No, so the interval symbol is parentheses. Is -3 included? Look at it. It's an open point, so it's not included, so I'm also going to use a parenthesis. There's only 2 types of symbols, either parentheses or brackets. Right now we're starting with parentheses. What does this mean in words, Mr. Q, this section? This means all real numbers greater than -3. And since this one has an arrow going to infinity, this is why this one's called an infinite interval. Infinite interval. All right? Let's go to the second one. Let's see. Where did I start? At my dividing point. What's my dividing point? 4. Okay. What does this shading region represent? Everyone? X, right? This shaded region could be any value, so that value has to be a variable. Okay? Question. What are all these numbers compared to 4? All these numbers compared to 4. Less than. And is this a solid point? Yes, so that has an equal sign. So, let's write our solution set for this one. Set notation X such that X less than or equal to 4. All right, let's write our interval. Look at the left side. The left side is continuing to go in which direction? That direction, and it keeps going to what? Negative infinity, because it doesn't stop. So it's going to go to negative infinity on the left side. How about the right side? It goes to what? To 4. So, do we ever catch up to negative infinity? No. Parentheses. Is the 4 included? Is it a solid point? Yes, so that means we're going to use a bracket to indicate that we do use 4. What does that mean? All real numbers less than or equal to 4. And since one of these sides is going to infinity, that's what we're going to write infinite. 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 All right, next one. What's my dividing point? -2. How about over here? 5. What goes in between? X, yeah, because all this is represented by X, and then arrows to the left. And since these are open points, we don't need equal signs, yes? All right, set notation. Solution set of X such that -2 less than X less than 5. Here goes interval. What's on the left side? -2. On the right side, 5. Open or close points? Open, so parentheses and parentheses. And what does this mean? How can I say this in words, that section? All real numbers between -2 and 5. Question, does that interval go to infinity? No, it stops right there, so that's why this is a finite. Finite. All right, you do the last one by yourself, and note, look up, this point right here is an open point. It's an open point. All right, we'll give you some time. Go. Hold on. Jaden, pass someone. Jose, dividing points. -1. What do I write in between? And all right. Is he missing anything, guys? Yeah, the equal sign where? At -5, because it's a solid point, so it has an equal sign. Yes? All right, hands if you got that. Solution set of X such that -5 less than or equal to X less than -1. Dividing point is -5, comma, -1. Is -5 a solid point? Yes, so we use a bracket. This was an open point, so we use a parenthesis. Hands if you got that. All right. And this says all real numbers between -5 and -1, comma, including what else? Yeah, -5 in this case because it's a solid point. Yes? Yeah, including -5. And this is a finite. So your home plate for tonight, part of it, is for you to write an inequality. Do we know how to do that? Yes. Set notation, do you know how to do that? Yes. And your interval notation. From 1 to 5, how comfortable are you with that? All right. All right, next we get to the next section, which is, I love this section, the graphing section. Get your graph in front of you. You need a highlighter. All right, here we go. With your highlighter, highlight this section, please. In one of the graph coordinate planes. So, and this reminds me of, guys, I don't know if you guys still have this game. Who's heard of Space Invaders? Anybody heard of Space Invaders? Remember that the ship is down here, and then when you shoot, it throws a shot going upward. Well, back in my day, it only shot one bullet at a time. But I know now the new ones, I think they shoot like a laser, and it keeps going. A laser keeps going like that. That's what this reminds me of, a laser going upward. However, check this out. Tell your neighbor, from what x value to what x value are you highlighting? From what x value to what x value are you highlighting? Let's see, from what x value, Steve? From 2 to what? To 8. Hands if you highlighted from 2 to 8. Yeah, okay. All right. Switch to another little coordinate plane, and I want you to highlight the following. And tell your neighbor the x values from where to where, from left to right. From where to where are you highlighting on the next one? Let's see, help me out, Valente, from where to where on the x values? -3 to 3. Let's see, from here to here. Hands if you agree with that? Yeah, from -3 to 3. All right. Now check this out. When I ask you to highlight a certain section like that, and I ask you for the domain, what is the domain? X values, is that correct? Look up really quick. Look what I'm going to write. From -3 to what? 3. Since it's the domain, that means I need to write x in between, less than or equal to, less than or equal to. You already following so far? We're not looking anywhere else. We're just looking at the x-axis, okay? Go to another coordinate plane. Do this section. And tell your neighbor the domain that you're going to highlight from where to where. What's the domain from where to where? Ivan, from where to where? From -9 to 4. Hands if you agree with -9 to 4. Yes. So how do I write that as a domain? From -9 to 4. What goes in between? X, less than or equal to, less than or equal to. How we doing? Yes? All right. Fairly simple how to read. Yes? All right. Turn your graph to the other side. Now we're going to practice the opposite direction. Look up, shade this portion. Can you guys see it? Yeah? Okay. Now, how do you read when we're going sideways like this? We read it from the bottom to the top. So turn to your neighbor. From where to where are you going to highlight? From the bottom to the top. What y values? What y values are we looking at that we're going to shade? Tell your neighbor, please, from where to where, before I ask Jalen for it. From where to where? All right, from where to where, Jalen? from 1 to 9. Hands if you agree with that? Yeah, that is correct. All right. So now check this out. I went from 1 to 9. 1, look up, to 9. But now what am I looking at? I'm looking at the y-axis. So that means I write the y in between, less than or equal to, less than or equal to. And this is what we know as the range. The range when we're looking at y values. Let's do another one. Go to the another little graph. Do that section. And tell your neighbor the range that you're going to highlight, the range. Christina, what's the range? -3 to what? To 1. So I'm going to write -3 to 1. What goes in between? Y, less than or equal to, less than or equal to. All right. I think we get the idea as to how to write the domain for the x and for the y. So far so good? Yes? All right. This next part, though, is the part that you're going to be doing the last section of your home plate. Ready? Go to one more coordinate plane and copy this. I want you to plot a point at -5, -2. Another point at 7, 4. And draw a segment from there to there really quick. Should have one blank, right? All right, so check this out. Whenever I give you a graph like this, look up. I always read it from left to right. So if I start from the left over here, my first point I encounter is this one right here. Is that correct? So if I was to highlight up and down like I did earlier, it's going to look something like this, starting right there. Is that correct? So check this out. So if I was to ask you for the domain of this graph, the blue graph, by looking at the highlighted section, tell your neighbor the domain for that section. What is the domain for that section? From where to where? -5 to what? To 7. So my domain would be -5, 7, x less than or equal to, less than or equal to. How do we write that in set notation? Frida, go. Set of x such that -5 less than or equal to x less than or equal to 7. Hold on. One last thing. How about interval notation? -5, comma, 7. Since we have a solid point here, it's a bracket. And a solid point over here, it's also a bracket. And that's how you do the domain. So how do we do the range? Let's see. As you're packing up, look up. As you're packing up, watch. There's my domain. Here's my range. Tell your neighbor from range, from where to where on the y values. From where? -2 all the way to what? Yeah, so my range would be -2 to 4 with the y. There it is. Set notation and interval notation. All right, guys? Tutoring after school, have a good one. See you then, or see you later. Bye.